Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 5.2, Linear Transformations of Roots. So when we are trying to find a certain polynomial expression, sometimes you're given a root and you're supposed to find all the roots, then carry out some form of transformation. Maybe you double the roots, maybe you triple the roots, take 2, or maybe you divide the root by 4, then add 3. Who knows? Sometimes you're asked to do that, but most of the time you are just given a polynomial and given a certain statement that says the root of the polynomial is alpha, beta, gamma, delta. Then there's a function g with roots, some transformations of alpha, beta, gamma, and delta, and you're supposed to find the polynomial g. It's kind of straightforward to do, given that you know the coefficient relations from last video, but you're only limited to learning linear transformations of roots, not to quadratics, nor cubic, nor quartics, so you're kind of safe in that regard. Let's try an example of linear transformation. So I have a function f(x), which is x cubed take 7x plus 6, with roots alpha, beta, and gamma. Now I want to find function gx, where its roots are 2 alpha take 1, 2 beta take 1, and 2 gamma take 1. So let's first of all find the coefficients. The coefficients are in turn a equals to 1, b equals to 0, c is -7, d is 6. So we have these informations. We know that beat on a, or minus b on a rather, is equal to alpha plus beta plus gamma, and we know c on a is alpha beta plus alpha gamma plus beta gamma. D on a negative is equal to alpha beta gamma. So I have these informations. So now after transforming like so, we can basically substitute in the values and try to find a equivalent b value, or b, c, and d value. We know that a is 1, so we can just take that away, it doesn't matter. And rather than alpha plus beta plus gamma, we have 2 alpha take 1 plus 2 beta take 1 plus 2 gamma take 1. So let's use red for gx. So we know that minus b is equal to 2 alpha plus 2 beta plus 2 gamma take 3. Then we have, actually let's try to factorize this whole thing into 2 lots of alpha plus beta plus gamma, and that would be the new minus b. We know that alpha beta gamma is, alpha plus beta plus gamma is minus b, so it is essentially minus 2b take 3 equals to the red minus b. So red is related to gx and black is fx. So we know the inherent value of b is 0. So we have minus b equals to minus 3, which means that b is 3. Sort of simple, isn't it? Now try alpha, beta, alpha, gamma, and beta, gamma. When you have a combined multiple and if you have a scalar transformation with an addition or subtraction, or we call translation, then you have a polynomial that you need to kind of expand, which is kind of annoying, but you know what, you can't avoid doing that anyway. So let's have a go. Let's see, I should do 2 alpha take 1, 2 beta take 1, add 2 alpha take 1, 2 gamma take 1, then add 2 beta take 1, 2 gamma take 1. So that I need to expand. That gives me 4 alpha beta take 2 beta take 2 alpha take add 1, add 4 alpha gamma, and you see what I'm getting at right now. Take 2 alpha, add 1, add 4 beta gamma, take 2 gamma, take 2 beta, add 1. So all of these looks complicated, but if you collect the like terms, aka the 2 multiplied and the single roots, we have 4 lots of C. So let's write down that's equal to 4 lots of C. Then we have 2 plus 2 minus 4. Take 4 lots of alpha plus beta plus gamma, which is minus b. Then we have 3 ones, so plus 3. So we have these, and that would equal to C. So 4 lots of minus 7, 0, plus 3, so minus 28 add 3 is minus 25, so C equals to minus 25. So this one is a bit more complicated. Finally we have the last one, and I need to clean up, I guess. So give me a sec, I'm gonna cut these out. And yeah, I'll take out the steps, they don't matter at this point. All that matters is the result that we have derived. So we've got these. Now we want to actually do some do the D version. So we know that minus D is equal to 2 alpha take 1 multiplied by 2 beta take 1 multiplied by 2 gamma take 1. So let's first expand the first one. We've got 4 alpha beta take 2 alpha take 2 beta plus 1 multiplied by 2 gamma take 1, which is also equal to 8 alpha beta gamma take 4 alpha gamma take 4 beta gamma take 2 gamma take 4 alpha beta add 2 alpha add 2 beta and take 1. So I've got this whole thing. Again, collect like terms. This is 8 lots of minus d. So we have 8 lots of minus d. Take 4 lots of c. And take 2 lots of minus b with a minus 1. So that would be minus d. And again, b is 0, take that away. We've got minus 4 lots of c, that's 28. 8 lots of minus d gives us minus 48, and take 1, so we have eventually minus d equals to, that's minus 20 minus 21 minus 21, so d is equal to plus 21. So there we go, we have all the coefficients, and don't forget the most important thing, write down the last equation, which should be, let's see, oops, that's the wrong pen, gx equals to x cubed, then find b is 3, add 3, x squared, c is minus 25, x, and d is 21. There we go. So that is the whole step of how to find linear transformations. It's a lot of steps. All of the steps are very easy to carry out, so it should not pose any difficulty for the ones who understand how this whole thing works. Just make sure that you do not miss out some terms. So sometimes these, if you miss out the 2 alpha 2 beta, then you're left with 1 negative 2 gamma, and you have no idea what that gamma is. So that would get you stuck. However, with linear transformations, it's guaranteed to have all of the roots in these conformations, such that you can factorize out the original sets of coefficients. And yeah, basically don't worry about things not cancelling out. It should. If it doesn't, check your working. You must have missed out something, or there must be a negative sign error somewhere. Actually, yeah, speaking of negative sign errors, there we have one. this might be plus actually. Where did I do this from? I cancelled out the. Yeah, I might have done a mistake, but the general idea is, yeah, basically the general idea is to expand everything, then what have I done? Let's see, I've got a negative. T lots. Huh. Interesting. Oh, this is add. Right, so I did do a mistake here. Oh well. Too much to change now. This will not be correct. But the steps are there. Just don't make arithmetic error like I did, and you should be fine. Well, ain't that embarrassing? Yeah, anyway, do check for algebraic errors because it matters. Although the steps would give you a lot of marks anyway. Do practice doing these transformations. I'm not gonna say that it will definitely come on, but it's good to know. It's technically not difficult. It's just a lot of steps. If you're a fast worker with, I don't know, calculus, or if you're fast with complex, you might have earned enough time to slowly do these grindy questions. So again, make sure you nail down the course content. Try to do the exam quite fast, but like slow enough that you don't make silly mistakes. Then you will have earned enough time to do these very, very boring and grindy old jobs. You're also required to know how to do up to quartic root transformations. Essentially the same thing, except a lot more steps. So in the question section, I'm gonna make some questions for you. The questions are shown here. We have a function f(x). Gx has double its roots, and ux has half its root take 2. So you're supposed to find gx and ux in this sense. They are all quartics. I'll give you, as usual, 5 seconds to pause the video to do these questions. And yeah, I'll show you the answer in 5, 4, 3, 2, 1. The results are shown here, and yeah, it's a lot of steps to do, and the ones who have gone ahead to find alpha, beta, gamma, and delta would realize there is a complex conjugate pair of roots. Yeah, so it doesn't matter if you didn't find the roots, it's fine. You just need to I'm just showing you that this method works for all polynomials, well, with real coefficients anyway. I'm not sure about complex polynomials. But yeah, that's it for linear transformations of roots. I hope you've learned something. If you have any questions, leave it in the comment section below, and I'll try to answer it as well as I could. For now, thanks for watching, and I will see you on my next one.